66 million years ago, our planet was an almost alien world, home to some of the most spectacular creatures to ever exist. Imagine a world without ice caps, where lush, dense forests stretched from pole to pole, and warm oceans teemed with life. This was the late Cretaceous period. And contrary to what some used to think, the dinosaurs weren't on their way out. Scientific evidence from fossils, sediment layers, and even preserved plant impressions tells us they were thriving, dominating a vibrant and stable Earth. Across the vast floodplains of what is now North America, huge herds of Triceratops roamed. These three-horned giants were like walking tanks, weighing up to 12 tons. They browsed on tough, low-lying plants like cycads and ferns, using their powerful beaked jaws and batteries of shearing teeth to grind up vegetation. Their very presence was a force of nature, shaping the landscape by clearing paths and influencing where certain plants could grow. They weren't just living in their environment. They were engineering it. And where there are herbivores, there are always predators. Looming large in this ecosystem was the one and only Tyrannosaurus rex. While we can't hop in a time machine to watch it hunt, fossil evidence like T-Rex tooth marks embedded in Triceratops bones tells a clear story of predator-prey relationships. Whether it was an active hunter or an opportunistic scavenger is still debated, but with its keen senses, bone-crushing bite, and sheer size, T-Rex was undoubtedly one of the most formidable land predators in Earth's history, a king ruling its domain. But this world wasn't just about the giants. It was a complex web of interconnected life. Insects, including early bees, buzzed among the newly evolved flowering plants, helping them diversify and spread across the globe. Hiding in the shadows and undergrowth were our distant relatives, small, shrew-like mammals. They were mostly nocturnal, avoiding the daytime dangers of larger creatures, surviving through sheer adaptability. And soaring in the skies were birds, the direct descendants of theropod dinosaurs, filling the air with patterns of flight both familiar and strange to our modern eyes. The oceans were just as dynamic. Beneath the waves, giant marine reptiles called mosasaurs, some stretching over 50 feet long, were the apex predators. The waters were filled with ammonites, those iconic spiral-shelled relatives of modern squid, along with massive sharks and countless species of fish. Vibrant coral reefs thrived in the warm coastal shallows, supporting bustling ecosystems that would rival anything we see today. Life was everywhere, from the deepest oceans to the highest mountains. Earth was a biological paradise. But far above this thriving, oblivious world, an object of immense power was hurtling through the silent vacuum of space. It was an asteroid, estimated to be about 10 to 12 kilometers wide, roughly the size of Mount Everest. We don't know its exact origin, but its chemical composition suggests it came from the outer regions of the asteroid belt between Mars and Jupiter. Its trajectory was set, its path unchangeable. It was on a collision course with Earth, and the planet's fate was already sealed. As the asteroid screamed closer, Earth's powerful gravity grabbed hold of it, pulling it in and accelerating it to an incredible speed of nearly 20 kilometers per second. That's over 44,000 miles per hour. From the perspective of the dinosaurs below, this final fatal approach was completely silent and invisible. There was no warning, no sense of impending doom. No creature on the planet had any way of knowing that their world was about to end. In the region we now know as the Yucatan Peninsula in Mexico, the day began like any other. Geological studies show this area was a shallow tropical sea, dotted with islands, reefs, and bustling coastal life. The sun shone brightly through the warm, humid air. Dinosaurs foraged along the shorelines, pterosaurs soared overhead, and marine life swam peacefully in the turquoise waters. None of them saw the brilliant, terrifying streak of fire that was about to appear in the sky. As the asteroid plunged into Earth's atmosphere, it compressed the air in front of it into a superheated plasma, hotter than the surface of the sun. Impact modeling confirms that in those final terrifying seconds, the asteroid became a celestial fireball, moving faster than the speed of sound. It would have been the brightest object anyone had ever seen, a blinding flash carving a fiery path through the blue sky. But it was moving so fast, the sound of its arrival wouldn't reach the ground until after the impact itself. Then, in a fraction of a second, the moment that changed the course of life on Earth forever. The asteroid struck. The impact was cataclysmic, releasing energy equivalent to billions of nuclear bombs exploding all at once. It blasted a crater into the Earth's crust over 150 kilometers wide and 20 kilometers deep, a scar now known as the Chicxulub crater. The sheer force of the collision was beyond human comprehension. The immediate devastation was absolute. A titanic shockwave, a blast of pure kinetic energy, radiated outward from the impact site, flattening everything in its path for hundreds of miles. The impact vaporized the ocean water and bedrock, sending a colossal tsunami. A wave perhaps hundreds of meters high, racing across the sea. An intense pulse of thermal radiation, a wave of unbearable heat, spread out at the speed of light, igniting forests and grasslands across entire continents. In just a matter of minutes, the vibrant, thriving world of the late Cretaceous was plunged into a nightmare. The sky turned dark, the air filled with ash and fire, and the ground shook with unending earthquakes. The paradise that had existed for millions of years was gone, replaced by a global catastrophe, but this was not the end. It was only the beginning of the long, dark day that would change the planet forever. Just hours after the impact, a colossal cloud of dust, ash, and sulfur surged into the sky. Peer-reviewed studies confirmed this wasn't just a local event. These particles formed a global haze that literally blotted out the sun. Imagine the bright, clear skies of the dinosaur era suddenly dimming, as if a permanent eclipse had fallen over the entire planet. The day had turned into an unending twilight. Without sunlight, the very engine of life on Earth sputtered and died. Photosynthesis collapsed. Plants withered. In the oceans, plankton, the foundation of the entire marine food web, vanished in staggering numbers. Herbivores, with nothing left to eat, were the first to starve. Soon after, the carnivores that hunted them faced the same fate. Entire ecosystems, built over millions of years, were unraveling in mere weeks, and the chaos didn't stop there. Fires raged across continents, ignited by the searing heat of the impact. We know this because geologists have found a thin layer of soot spanning the entire globe from that exact time. Meanwhile, the planet itself was in turmoil. Massive earthquakes and tsunamis, triggered by the initial impact, continued to shake the crust, rearranging coastlines and landscapes. The darkness dragged on for months, maybe even years. As the sun's warmth faded, temperatures plummeted. Scientists call this an impact winter. The world was plunged into a prolonged period of freezing cold, perpetual darkness, and a toxic atmosphere thick with pollutants. For most species, it was a death sentence. There was simply nowhere to hide. The casualties were immense. Ammonites, those iconic spiral-shelled creatures that had thrived in the oceans for hundreds of millions of years, disappeared forever. The great marine reptiles, the mosasaurs and plesiosaurs that once ruled the seas, vanished without a trace. And on land, the non-avian dinosaurs, the titans of the Mesozoic, couldn't adapt to the sudden and total collapse of their world. But life is tenacious. Not everything perished. Smaller animals, like our early mammal ancestors, certain reptiles, and some birds, managed to survive the apocalypse. How? Fossil evidence suggests they used a variety of strategies. Many were small enough to burrow underground, sheltering from the worst of the cold and chaos. Others were omnivores, able to scavenge on whatever they could find, from insects to roots to carrion. Eventually, ever so slowly, the dust began to settle. The atmosphere cleared, and sunlight once again touched the surface of the earth. With its return came warmth, and with warmth, the first green shoots of new plants. Life began its gradual revival. But the world that emerged was a shadow of its former self. Entire ecosystems were gone, and it would take millions of years for the planet to fully recover. In this new, emptier world, mammals saw their chance. With the dinosaurs gone, the ecological stage was wide open. They exploded in diversity, evolving into new shapes and sizes, and filling the niches left vacant by the giants. This incredible evolutionary journey would ultimately set the stage for the rise of primates, and eventually us. And what about the dinosaurs? Well, not all of them went extinct. One branch of theropod dinosaurs survived. We know them today as birds. Their ability to fly, their small size, and their adaptable diets likely gave them the edge they needed to endure the catastrophe. So when you see a bird outside your window, remember you're looking at a living dinosaur. Over millions of years, the earth healed. Forests regrew, rivers carved new paths, and the oceans restabilized. But it wasn't a return to the old world. It was the beginning of a completely new chapter in the story of life. The age of mammals had begun. The Chicxulub impact was more than just an extinction event. It was a planetary reset button. It reshaped Earth's climate, atmosphere, and the very course of evolution. A thin layer in the Earth's crust, rich in an element called iridium rare on Earth, but common in asteroids, serves as a permanent tombstone for that day, silent witness to the cataclysm. The age of dinosaurs ended in a flash of cosmic violence, but their legacy lives on in the birds that fill our skies and in the incredible fossil record they left behind. The end of their reign was the beginning of ours. By understanding that one terrible day 66 million years ago, we gain a profound perspective on the fragility of life and the deep history that connects us all to a world long gone. Thanks for watching, and if you enjoyed this journey back in time, be sure to subscribe for more.